Hello viewers, my name is Mr. Adebanjo. I want to welcome you to my video. I want to sincerely welcome you to this video on WAEC 2023 further mathematics theory questions. That is, we are going to be solving the just concluded WAEC 2023 further mathematics theory. So, and in this video, there are a lot of things we'll be doing, and some of them are highlighted here. We are going to be telling you the topics where the questions were picked, and as we solve each of the question one after the other, we will tell you the question where the topics where the question originated from, and we also solve each of the questions systematically, step by step, and also tell you the expectation of the examining body from the students, and also the likely errors made by the student during the course of the examination. So there are a lot of things packed in this video. So I want you to sit down and follow us as we explain in details each question for you. But before we get it started, if you are yet to subscribe to this channel and you have been benefiting from the channel, please click on the subscribe button on the screen on the channel right now, and share the video with students out there who need this resource material. Yeah, you can comment in the comment section of this video so as to help us improve in our next video. And I believe you're going to learn a lot of things in this video as we solve together the WAEC 2023 further mathematics theory. Like we have solved the objective question of this further mathematics. So if you want to see the video, and you can check the playlist of this video. There you will see the video we made on the objective of this 2023 further mathematics. So also, before we get it started, are you in need of wisdom? There is one called the fountain of wisdom. Do you seek knowledge? There's also there's one called the fountain of knowledge, who has all the knowledge, the wisdom in abundance. Do you need understanding as a learner or in your business, in everything you do? There's one called fountain of understanding as well. His understanding cannot be quantified, cannot be searched out. And who is the person I'm talking about? The person of Jesus Christ, the Son of the living God, who came into this world to die for my sin and the sin of the world, so that we may see God, so that we may have fellowship with God. So if you are in need of knowledge, wisdom, and understanding in everything you find yourself doing, you can get it from Jesus. And you cannot get it from Jesus unless you accept Jesus as your Lord and a personal Savior. So ask Jesus to come into your life today, because it's the only way to the Father, the Almighty God. Jesus is the truth, the light, and the way. So accept Jesus as your Lord and personal Savior today, so that He can flourish your life with understanding, with wisdom, and with knowledge. You can reference the scripture on the screen right now, John 3:16, who said that for God so loved the world that He gave us His only begotten Son, Jesus, to die for you and I, so that we may know God. Accept Jesus today into your life, so that it shall be well with you. Thank you. Now we are going to start solving the WAEC 2023 further mathematics theory question. And the first question is what you are seeing on the screen right now. And the question is from combination. It's from combination. We know that there's combination and permutation as a topic in further mathematics. So, but this question originated from combination. The question said that if 9 combination x is equal to 4 into bracket 7 combination x minus 1, you have to find the value of x. So It's quite simple as well. You just need to follow it step by step. Now, how can we write a 9 combination hex? That can be written as 9 factorial over 9 minus x factorial x factorial. If you understand combination, you know that this can be written as this equals to 4 into brackets 7 factorial also, sorry, 7 combination x minus 1 also can be written as a 7 factorial over 7 minus open bracket x minus 1 factorial, then x minus 1 factorial, close the brackets. So if you understand the combination very well, then this will not be a problem to you when we simplify this like this and this like this as well. We have followed the same principle of combination. So from there, what can be done? We can open this bracket here. You have 7 minus x plus 1, which is this factorial x minus 1 factorial. Then from there, we know that 4 will multiply this 7 factorial. So from there, we can cross multiply. 4 times 7 factorial will cross multiply like this. This one will multiply the down. This 4 times 7 factorial will come under. This one will go up here. So technically, you'll be having 9 factorial over 4 times 7 factorial equals, so this one comes here, 9 minus s factorial over 7 minus x plus 1 factorial s minus 1 factorial. So if you don't understand this, you can do step by step, can cross multiply, then you are at the end of the day, you see arrive at this. Now why are we doing this? Now we can simplify this one further. Of course, 9 factorial will give us 9 times 7, no, sorry, 9 times 8 times 7 factorial, so that this 7 factorial can take care of 7 factorial under. Then also 7 plus 1 will give us 8 minus s factorial. Then also we can expound this s factorial, so that should give us s into x minus 1 factorial, so that s for minus 1 factorial can take care of s minus 1 factorial here. So if that is the case, let's do this 7 factorial cancel 7 factorials. That means we have 9 times 8 left over 4. Then 4 can go in 8. That will give us 2 times 9 will give us 18. Then the s minus 1 factorial cancel s minus 1 factorial. So you are left with 9 minus s factorial multiplied by x over 8 minus s factorial. Then we can also simplify 9 minus s factorial, and that should give us 9 minus x into, if you remove 1 from here, you have 8 minus x factorial x over 8 minus x factorial. So this can take care of this. So we have left with a 9 minus x times x, which if you open the bracket, we have 9x minus s squared. So we have 9x minus s squared is equals to 18. Then from there, this 18 can come here, or better still, we can take 9 minus s squared to this side. That means we'll be having s squared minus 9x plus 18 equals to 0, which is a quadratic equation to be solved. Then if you simplify this quadratic equation using factorization method, then you'll be having s minus 3 into s minus 6 is equals to 0. I believe you should know what you have done here to get this. Then from there, s minus 3 is equal to 0, s minus 6 is equal to 0 as well. So technically s will be 3 or s will be 6. So the values of x is s is 3 or s is 6 for this question number 1. Question number 2 is from application of differentiation. It's application of differentiation. We are told that the volume of a cube is increasing at the rate of 3 number 1 over 2 centimeter cube per seconds. Find the rate of change of the side of the base when its length is 6 centimeter. Like I said, it's from differentiation, that is the application of differentiation. So the volume of a cube, what is the volume of a cube? Volume of a cube, it should be the side of the cube of the side of the cube. So if the side is x, so that means the volume will be s cube. So if the side of the cube is s, so the volume will be s cube. Then we can differentiate v with respect to x. That should give us the v dx equals to 3s squared. Then from there, we are told that the volume of the cube is increasing at the rate of this. So the volume is increasing, that should at a particular rate. So that should give us a dv dt. So the volume is increasing at a particular rate. So that should, if you differentiate the volume with the time, that should give us dv dt equals to this rate given to us, which if you change to improper fraction, that should give us 7/2 centimeter cube per seconds. Then from there, you know that we are looking for we have to find the rate of change of the side. So that should give us the SDT, the rate of change of the side. That should give us the SDT. So from there, we should know that if you use a chains rule, which is a function of function, dv dt, which you have here, is the same thing as a dv over the x times ds over dt, because if the s cancel the s, you have the dv over dt back. So from there, our aim is to find the rate of change of the side, which is the s dt. We already have the v dt equals, so we also have the v dx, which is what you're having here. So if you substitute that, we have a 7/2, which is dv dt equals to dv ds is a 3s squared equals to the s dt, which is what we're looking for. So if you make this the s dt such of the formula, that means you divide both sides by 3s squared. So that should give us the s dt equals to 7 over, if you divide both sides by this, that should give us a 7/3 times s squared. That should give us 7/6s squared. But we are given the side of the cube, which to be 6. So that means you'll be having 7/6 times 6 times 6, because s is side is 6. So that means you have 6 squared. So technically you'll be having 7/612 centimeter centimeter per seconds. Or if you change it to decimal number, you'll be having 0.032 centimeter per seconds as the rate of change of the side of the cube. So that's the second question we have just completed. Now the third question is from the function. Is from function, mapping and function, and that is a question SS1 topic, mapping and function. In this case, you are told that the inverse of a function f is given by f of x inverse f of inverse of x, f inverse of x equals to 5x minus 6 over 4 minus x, where x is not equal to 4, because if x is equal to 4, then this fraction will become undefined fraction. So we are to find the value of a function of x, then b, we have to find the value of x for which f of x is equal to 5. So technically, we are given the inverse of a function, so we want to know the function itself. So we are given the inverse of a function, which is this, to know the function itself, which is f of x. So they have simplified this function to get this. So they have found the inverse of this function to get this one. So knowing this one, I want us to get the function back. How do we do that? It's very simple. So this inverse of x here, you can call it y, knowing that it is not f of x, because f of x can also be called y. It can be called y, but we know that this f of inverse of x we are calling it y now, which is equal to this 5x minus 6 over 4 minus x. So from there, we can make x the subject of the formula by cross multiplying. If you cross multiply, you have y into 4 minus x equals to 5x minus 6. Open the bracket, you'll be having 4y minus xy equals to 5x minus 6. Collect like terms, because we want to make x solve the formula. So if I bring minus sy into this side, I will have 5s plus xy equals to, then I'll take this minus 6 to this side, I have 4y plus 6. From there, I can factorize x out here. So I'll be having x into 5 plus y, then equals to 4y plus 6. Our aim is to find x. So that means divide both sides by 5 plus y. So that means s will be equal to 4y plus 6 over 5 plus y. So now we can now swap the variable. So this one become x, this one become y, pardon me for that. This one become y, then this y here become x. So that means you'll be having y is equal to 4x plus 6 over 5 plus x. So knowing that this y we have gotten here is not the same thing as this y this y is standing for inverse, then this y is standing for f of x, which is the function you have to find. So therefore f of x will be 4x plus 6 over 5 plus x. Then the question said that the question B said that we have to find the value of x for which f of x is equal to 5. So our f of x is this, so it's equal to 5. So technically equate this one to be equal to 5. Then cross multiply from there. You have 5 times 5 will give us 25. 5 times x will give us 5x equals to 4x plus 6. Collect like terms from there. You'll be having 5x minus 4x equals to 6 minus 25. 5x minus 4x will give us x, then equals to 6 minus 25 give us a minus 19. So technically x is equal to minus 19 for question number 3b. Now that's the solution for question number 3. And let's go to question number 4. Question number 4 is from a sequence and series. It's from sequence and series and a arithmetic progression to be precise. So the question said that the first term of an arithmetic progression is minus 8. It's minus 8. Then the last term is 52. And the sum of the terms is 286. You have to find question number A, the number of terms in the series. Then you have to find the common difference. So it's quite simple as well. Like I said, we are given the first term. The first term of an arithmetic progression is what? It's A. The first term of arithmetic progression is A, which is equal to minus 8 here. And the last term is 52, so we can say L, which is representing the last term, is equal to 52. And the sum of the term is 286. So we have sum of the term, which is Sn, is equal to 286. So we have to find the number of term, which is talking about the value of n here. So you are looking for the n as the number of terms. So we know that for summing terms in AP, we have two formulas. The sum of term equals to n over 2 into 2a plus a open bracket n minus 1 close the bracket d, then close the big bracket. And there is this second formula that is related to the last term. Sum of term is equal to n over 2 into a plus l. So we cannot use the first one I said here, but we can use this one to solve this question. So because we are given the last term and we know the first term, and then we know the sum of the terms, the value of the sum of the term, which is this, so we can find our n from there. So if you substitute here, you'll be having sum of term, which is 286 equals to n over 2 into first term is minus 8 plus last term, which is 52. Minus 8 plus 52 will give us 44. It multiplied by n over 2. From there, 2 can go in 44. That should give us 22 times n. That gives us 22n. You can divide both sides by 22. That should give us 13. So that means that we have 13 terms in this sequence. We have 13 terms in the AP. Now that we know the number of terms in the AP, we know our first term. We have to find the common difference, which is D. And how do we do that? We know that the last term, which is the n term, which is as last term, is equal to a plus n minus 1 multiplied by d. The last term is 52 is equal to first term is minus 8 plus our n is 13 because we have 13 terms there, minus 1 multiplied by d. 13 minus 1 will give us 12 multiplied by d will give us 12d. From there, we can collect like terms. 8 can come here, so you have a 12d equals to 52 plus 8. That gives us 60. Divide both sides by 12, d will be equals to 5. So the common difference for the sequence is 5. And that's the solution for question number 4. Question number 5 is from statistics and histogram, to be precise. And I must confess to you that the majority of the students who solved this question got it wrong. Or got it wrong. So because of a simple mistakes made by the students, which I'm going to be highlighting in this video. The question says that the table shows the distribution of the height in centimeter of 60 seedlings in a vegetable garden. You are given the height with a class interval, and we are given the frequency. You have to draw a histogram for the distribution. Now, Majority of the students will get who represented the height in this format, which is the talking about the class interval. You have been given that. You write that vertically like this. Then to draw histograms, we need class boundaries. We don't need the class interval to draw histogram. Rather, we need class boundaries because the blocks need to be joined together. So the blocks we need to join together. So the class interval cannot make the block to be joined together. Rather, class boundary will make the blocks to be joined together because we know in histogram all the blocks are joined together. It is bar chart that the blocks are separated. So that means we need class boundaries. And how do we get class boundary? You can get class boundary from the interval, from the class interval. So from the lower class interval, you remove 0.5 and you add 0.5 to the upper class interval. So remove from 0.5 from here, you will get this. Add 0.5 to this, you get 0.35. Are we there? Remove 0.5 here, you get 0.35. Add it to this, you get 0.65. Then remove 0.5 from here, you get 0.65. Add 0.5 to get 0.95. Then you remove 0.5 from this, you get 0.95. Then you remove 0.5 from this, you get 1.45, and so on till you are done. But you can see that normally you are supposed to use this class boundary and the frequency to draw the histogram. A normal histogram with the same class size throughout the interval. We don't need this two column. So we only need the class boundary and frequency, then we can draw the histogram if the interval have the same class size. But if you look at this histogram given to us, the histogram does not have the class interval does not have the same class size throughout. Look at this first one. The class size is 0.3, 0.3, 0.3. This one has 0.5, 0.5, 0.3, 0.3. So there's no the histogram does the class interval does not have a constant class size. So at the end, that means that we cannot use just this and this to draw the histogram. We cannot use this frequency to draw the histogram. If you do that, you will be wrong. So then what do we use to how do we draw the histogram? So you get the class size first for each of these interval. How do we get the class size? That should be the upper lower class size here. This minus this, that should give us 0.3. 0.7 minus this, that gives us 0.3. 1.0 minus this should give us 0.3. 1.5 minus this should give us 0.5, and so on till you get everything there. I hope you are clear. Then how do we then you are not going to get frequency density. You're going to get frequency density, and this is how you get frequency density. And I've already I wrote the formula on the screen right now. Frequency density is equals to the frequency divided by the class size. So that means you have for this one now you have 0.3 divided by 6, that should give us 20. 0.3 divided by 9, that should give us 30. 0.3 divided by excuse me 12 divided by 0.3, that should give us 40. 15 divided by 0.5, that should give us 30. 3 divided by 0.5, 6, and so on as well. So in drawing the histogram, you are not going to use the frequency and the class boundaries. You are going to use the frequency density and class boundary to draw the histogram. You should know the reason for this because the class interval does not have a constant class size. The class size varies. So had it has constant class size, then you don't need to find the frequency density or this one. You can just use these two and this to draw the histogram straight away. I hope you are following. I hope you understand that. Then having gotten this, now you can now go and draw the histogram with these class boundaries and the frequency density. Frequency density will be on the y-axis and the class boundary will be on the x-axis. Then if you draw the histogram with this, then you'll be having something like this on the screen right now. So you can see that the frequency density is on the y-axis with a scale of 5 units for 2 centimeter. So also you can see that on the x-axis you are having the class boundaries. The class boundaries you're having, these class boundaries is what you're having on the on the x-axis. So from there now I can start plotting the graph from 0 point, let's go back from 0.05 to 0.35. You have it frequency density to be 20, and that is what you're having here. 0.5 to 0.30, you have it to be 20. So you can see that the block is represented by this. Then the next one is from year to year you have 30. From 0.35 to 0.65 we have we have 30, and that is related by this block as well. Then the next block you have this, the next one is this, the next one is this, and to the last one. If you draw it your own histogram very well, you are supposed to be having something like this. So then let's go back. We have to do something on the histogram. We have to find the modal height. We have to find the modal height of the histogram, which can be gotten from the graph, and that is going to give, you can get down from this the highest block here, the block with the highest frequency density, which is this block. What do? You draw with your a straight with your ruler and with a pencil or a biro. Join this edge to this edge and this edge to this edge, and where those two line intersect, you draw it down to the height and you read it. Then that should give you the modal the mode of the histogram, and that should give us a 0.80 plus or minus 0.05 centimeter. So that's for question number 5 on histogram. Now question number 6 is from combination and probability. So we are having two topics combined for this question number 6, and I hope you understand it. The question says that there are 6 boys and 8 girls in a class. So you should know that this one is you can solve, this one is related to combination, it's also related to probability. If 5 students are selected from the class, then find the probability that more girls than boys are selected. So we know that probability is talking about the favorable outcome over total outcome. So favorable outcome over total outcome. So probability that more girls than boys are selected is equal to, we need to get the favorable outcomes over total outcome of picking 5 from what's it called, 14. That should be 14 combination 5. So picking 5 from 6 plus 8 give us 14. So 14 combination 5 will give us how many ways in which 5 can be picked from 6 to 6 plus 8, which is 14. And that should give us a total outcome. Then we need to get the favorable outcome, which is the numerator here, and that says that more girls than boys, more girls than boys. Don't forget that the total people, those total students that must be picked are 5. Then if you have 8 girls, so the girls should be more than boys. So that means if you pick 3 girls, you'll be picking 2 boys. That's give us 3 plus 2 give us 5. Then 3 girls will be from the 8 girls multiplied by 6 from 2 from the 6 boys. Or not only this, you can have another option. You can still pick 4 girls, then you'll be picking 1 boy. That should still give us 8 combination 4 times 6 combination 1. 4 girls, 1 boy. Or you can also pick 5 girls and 0 boys, because we are told that that more girls than boys are selected. So we have 8 combination 5 times 6 combination 0, and 6 combination 0 will give us 1. So that's why we are having this. So if you simplify this, we have 8 combination 3 give us 56 times 6 combination 2 give us 15 plus 8 combination 4 give us 70 times 6 combination 1 will give us 6 plus 8 combination 5 give us 56 times 1. This is an omission here, sorry for that. Then from there, if you want to simplify it, you have 840 plus 70 times 6 will give us 420. 56 times 1 will give us 56 over 202, which is 14 combination 5. If you had this, you have if you had this, then simplify it, you have 94 over 143, or you can simply write a 0.6573 as a decimal number for this. So that's the solution for question number 6. It's quite what's it called, straightforward, and sometimes it could be confusing somehow. But if you sit down with this, you understand that what you have done here systematically. Question number 7 is from the motion. It's on a rectilinear motion on a straight line. A ball travels with a velocity of 6 meters per second. It then accelerates uniformly and travels a distance of 70 meters. If its final velocity is 20 meters per second, find the correct with one decimal place, the acceleration, then B, find the time taken. So it's quite very simple. Like I said, it's from the uh, motion on a straight line, which is rectilinear motion. Now we are given the initial velocity to be 6, which is u is equal to 6 meters per second, and we know the final velocity, which is 20 meters per second as well. We are told the distance the ball covered, which is 70, as our x. So we are looking for acceleration, which is a. So you need to remember which of the equation of motion that is related to what we have here. You know, we have like 3 or 4 equation of motion, but the one that is related to what we have here is the one that we have v squared equals to u squared plus 2as. So we have our v, we have our u, we have our x, and we are looking for a. So if you substitute this value here systematically, we have 20 squared equals to 6 squared plus 2 times a multiplied by 70, which is our distance. Then from there, 2 times 70 will give us 140. 20 square will give us 400. 6 square will give us 36 plus 140 a. Collect like times. We have 140 a equals to 400 minus 36, and that should give us 364. You can divide both sides by 140, and that gives us acceleration to be 2.6 meters per second squared. So that's the acceleration at which the bus was traveling. Then you have to find the time taken by the bus, and you need to remember equation of the motion as well that's related to time. We have v is equal to u plus 8a. Our v is 20 equals to u 6 plus 2.6, which is the acceleration we got here, multiplied by the t. Then if you collect like times, also we have 20 minus 6 will give us 14. Then 2.60 equals to 14. Divide both sides by 2.6, so t will be 5.4 seconds. So that's the question 7, and it's quite simple and quite straightforward as well. Let's go to question number 8. Question number 8 from vector. Question number 8 is from vector, and it's related to vector, related to the triangular law of vector, which is talking about the addition and the subtraction of vector. Now we are told that P is the midpoint of vector NO and equidistant from vector MN and MO. If vector MN is equal to 8i plus 3j and vector MO is equal to 49 minus 5j, you have to find vector MP. So it's quite simple. We have 3 positions for the vector. Of course, now we know that we are talking about N is here, M is here, then O here. So you have 3 point M and O. So which can form a triangle for us. So if you draw the triangle MNO, and we are told that there's a there's MP, there's a point P rather, there's a point P, which is the midpoint of NO. This is NO here, and there's a midpoint here P. So if you can draw to M here, that will give us MP. You have to find here. Then from there, it's quite simple. Now, using the triangular law of a vector from triangle MNO, this big triangle, we know that vector MN should be equal to vector MO plus ON. That's what you're having here. This is triangular law. Triangular law say that vector MN should be equal to MO plus ON. And that's what you're having here on the screen right now. This is triangular law of vector. Then from there we can make, since we know our mn, we are giving vector mn, we are giving mo as well. So we can make on solve by the formula. And make this one a formula, that means this one comes here. That means you have vector on equals to mn minus mo. Our mn is 8i plus 3j minus open bracket mo is 14i minus 5j. Then if you open this bracket with minus, then you'll be having 8i plus 3j minus 14i plus 5j. Collect like times, we have 8i minus 14i, that should give us a minus 6i. Then we have a 3j plus 5j, that should give us a plus 8j. Now, we question give us that the P is the midpoint of NO. We have ON here, not MO. We have vector OM. That's what we have gotten from the triangular law. But we need NO, not ON. So that means the vector ON and MO have the same magnitude but different direction. So that means this one is going here. If you come back here, that means this one become, you need to introduce minus. So if our ON is this, that means NO, that means you are changing, I'm changing direction from, instead of from here to here, that means I'm going from here to here, and that's what this arrow means. So we are going from N to O now. That means you need to introduce minus against this vector ON. So if you introduce minus to it, that means this one become plus, this one become minus. So that means we now have a vector NO now. Then from there, what can we do? Since P is the midpoint of NO, so that means vector NP should be half of whatever you are having here. Is that correct? Good. So vector NP should be half of NO. So therefore vector NP should be equal to half of whatever we got here, half of 6i minus 8j. If you simplify that, that should give us 3i minus 4j, but let's leave that for now. Then also from this triangle, this small triangle inside here, you can use this one, you can use this one as well. You see, give the same answer. For triangle MNO, we can also apply the triangular law, which says that vector MN should give us a vector MP plus PN. Vector NP should be equals to MP plus PN. Are we there? So our aim is to find okay, so our mn is equal to mp plus pn, but we need we have pn here, but we know np, not pn. So we know np to be this, so, and we have in here pn, so that means we can change the direction of this one to np. So that means we need to introduce minus. So if you introduce minus here, so that should give us a minus. Then this one will change from n to p now. So from there, what do we need? Our aim is to find vector np. So we can make this one a solid formula. Then this one comes here. So that means you have np equals to mn plus np. We know our mn. What's our mn? Mn is 8i plus 3j. We already know that one. Then our np we got here is this. So I said to take care of this, that means you have 3i minus 4j, which if you simplify, 8i plus 3i will give us 11i. Then 3j minus 4j will give us minus j. So therefore vector np is equals to 11i minus j. I hope you understand this. This is question number 8. Question number 9 is quite a little bit long, but we are going to solve it step by step. We are having differentiation and we are having trigonometric ratio. So question number 9 is from differentiation. Question number 9a is from differentiation. We have to differentiate this function with respect to x from first principle, and that's the first thing you learn in the differentiation from the first principle. Then if you do that, you are given y is equal to 4x minus 7 over x squared to differentiate y with respect to x from first principle. How do we go about that? We need to take the change of both sides, find the change of x, then find the change of y, find the change of x as well. So if I take the change of y, I have y plus change in y, equals to, I think the change of x here, I have 4 into x plus change in x minus over 7 over, I find the change of x here as well, I have x plus change in x all squared. Then from there, you can open the bracket here, you have 4x plus 4 change in x minus this. Then from there, we can make, you can take y to the other side. So that means you have a change in y equals to 4x plus 4 change in x minus 7 over this. Then if y comes here, it becomes minus y. So we need to record the value of our y is 4x minus 7 over s squared. So if you write that one, if you introduce that one here, I mean that minus will open the bracket, then you'll be having minus 4x minus times minus will give us plus 7 over s squared. I hope you understand this. Our y is this, so put that here, so that minus will multiply everything here, so you have 4 minus 4x plus 7 over s squared. From there, minus 4x, if you collect like times, minus 4x will take care of 4x. So we are left with 4 change in x minus 7 over s plus change in s squared plus 7 over s squared. Do you understand that? From there, we can factorize 7 out here. We have change in y equals to 4 change in x plus 7. Then into bracket 1 over s squared. We have rearranged as well. Supposed to be 7 into minus 1 over s plus 7 s plus change in s squared plus 1 over s squared, but we rearrange as well, so the minus come to the back and this plus come to the front, so it's still the same thing wherever you write it. Then from there you can find the LCM of the brackets, and the LCM will be s squared into s plus change in s squared. Then s squared in whatever we have here, that should give us a change in s squared, s plus change in s squared. Then multiply by 1 here, you give us what you're having here, minus this in whatever you have here, you have s squared left. S squared times 1 will give us minus s squared. Then from there, what can be done? We can open the bracket here. This bracket, the numerator here, s plus change in s squared, which means s plus change in s squared in 2 places. Then when you multiply the bracket and you collect like times, you have s squared plus 2x change in x plus change in s squared minus this s squared over whatever you're having here. Then s squared will take care of minus s squared. So technically we are left with 2s change in x plus change in s squared over this. Are we there? I hope you understand up to this point. Then from there you can divide both sides by change in x. Put divide both sides by change in x. So you have change in x over change in y over change in x equals to 4 change in x plus 7 change in x. How do we get this? How do we get change in x here? If you factorize change in x out here in the numerator, change in x is common here, so you factorize it out, so you have 7 change in x into 2x plus change in x, because here you're having s change in x squared here, so if you bring out one of it, you have change in x left over this. So I said we divide both sides by change in x, so you have this over this. Then what do we gain from that? Then change in s will cancel. Of course, you can break this one down if you don't understand what you have done here. That means you have 4 change in s over change in s plus 7 change in x multiplied by the bracket over change in x. Do you understand that? Then change in s will take care of change in s here. That means you have 4 plus change in s will also take care of change in s here. You have 7 into 2s plus change in s over s squared into s plus change in s squared. Do you understand that? Then if you understand that, that means you can take the limit of change in s tend to 0 of both sides. So if you take the limit of this using the L'Hospital rule, you don't need to understand that, though I understand what I'm trying to say. Then this change in y over change in s will turn to the y dx. Then take the limit of this side as well. Your change in s tend to 0. So you have 4 plus whatever you see change in s here, put 0 there. So that means you have 0 here, you have 0 here. So we have 4 plus 7 into 2s plus sorry, put 0 here, put 0 here, so you have 4 plus 7 into 2s plus 0 over s squared into s plus 0 squared. So here you'll be having s plus 0, which is x, then squared it, that means you have s squared. S squared times s squared will give us s raised to power 4, which is what you're having here. Then we are having 2s plus 0 here give us 2s plus times 7, that give us 14x. So technically you'll be having 4 plus 14s over s squared, s raised to power 4, pardon me for that. Then s can take care of one of the x here, so we have 4 plus 14 over s raised to power 3. So when you differentiate this using first principle, you get 4 plus 14 over s raised to power 3. Even if you differentiate it using the differentiation rule, you will still get the same answer. So that is the differentiation of this function used from the first principle. I hope you understand that. Let's do question number 9b, which is from a trigonometric ratio, tan. Trigonometric ratio of a compound angle, sorry. Not trigonometric ratio, not just trigonometric ratio, but trigonometric ratio of compound angle. Because you're having tan p minus q here, this is compound angle. Now, how do we do that? Given that tan p is equal to 3 over s minus 1 and tan q is equal to 2 over s plus 1, we have to find tan p minus q. So, from the trigonometry of trigonometry of compound angle, we know that tan p minus q will give us a tan p minus tan q over 1 plus tan p tan q. This is trigonometry ratio of compound angle, if you remember it. So equals to, we know tan p is 3 over s minus 1, which is what you're having here, minus tan q is 2 over s plus 1 over 1 plus tan p is this, multiplied by tan q, which is this. Do we understand? So we can find the LCM of the numerator and LCM of the denominator. So the LCM of the numerator here is s plus 1, s minus 1, which is the difference of 2 square. So we have that here. Then s minus 1 in this, that gives us s plus 1 multiplied by 3. We give us whatever you're having here, minus s plus 1 in this, that gives us s minus 1 multiplied by 2. We give us this, over LCM here is also s plus 1, s minus 1. So, which is this. The 1 in this will give us this, multiplied by 1 will give us this. Then, whatever you're having here, s plus 1, s minus 1 in this, that should give us 1. Then 1 times 3 times 2 will give us s plus 6 as well. Then from there, you can rewrite this one like this. This division can be written like this, so that you can change this to times. This one go, this one come down. So we have this. Then this can take care of this. So we are having this over this left. Then you can open the brackets. 3 times f give us 3s. Then 3 times 1 give us 3. Minus 2 times s will give us minus 2s. Minus 2 times minus 1 give us plus 2 over this is a difference of 2 square. S plus 1, s minus 1 is a difference of 2 square, which means s square minus 1, then plus 6. Then if you collect like times 3s minus 2s will give us x. Then 3 plus 2 give us plus 5 over s squared minus 1 plus 3 give us plus 5. So if you simplify this, you get s plus 5 over s squared plus 5, which is the simplest form of the fraction. Question number 10 is from polynomial. It's from polynomial, and is from the remainder theorem of polynomial. So it's quite long, and also is simple. So let's follow it step by step, and let's see how far we can go. We are given that question number 10a says that a quadratic polynomial. So that means we know the nature of the polynomial is a quadratic, and they call it g of x as 2s plus 1 as a factor. So this statement means something which you can interpret. So that means if I say 2 is a factor of 4, so that means when I divide 4 by 2, that means the answer I'm going to get should be a whole number, not a decimal number or any other type of number. So that means 2 can easily go in 4. Alright, let's go on. If g of s is divided by s minus 1 and s minus 2, the remainder are minus 6 and minus 5 respectively. So if you remember in okay, find we figure 1 g of x, then you have to find the the zeros of g of x. Now let me take you back to polynomial. That's the remainder theorem in polynomial. So we know that when you are to use a divisor to divide a dividend to get a quotient. So when the divisor divide the dividend and the remainder is 0, that means the divisor is a factor of the dividend. Does that make any sense to you? But when the divisor divide the dividend and the remainder is not 0, that means the divisor is not a factor of the dividend. So that's what it means. Now, how do we solve this kind of question? We are told that the quadratic polynomial, so that means you can the quadratic polynomial is a g of x. So that means you can say g of x is equal to a squared plus bx plus c. This is a quadratic expression and the quadratic template. A squared plus bx plus c, which is a quadratic polynomial. You can call it g of x, which is g of x rather. Then from this statement, d of x has a factor of 2x plus 1. So that means if this 2x plus 1 divide this g of x, the answer should be, the remainder should be what? 0. That's what it means, because this is a factor of this according to the remainder theorem. Then that means there are ways of getting the remainders of a function. So that means if I make this 2x plus 1 equals to 0, then I will get x to be equal to minus 1 over 2. That means if I substitute this value into g of x, the answer should give me 0. That's what it means, because this is a factor of this. So if I substitute minus 1 over 2 into g of x, the remainder should be what? 0, because this is a factor of that, and that was you have here. So if I substitute from this 2x plus 1, which is our s will be minus half. If I put that into this quadratic g of x, which is this one, then the answer should be what? 0. So anywhere I see x, I put minus 1 over 2. So that means we have a into minus 1 over 2 squared plus b into minus half plus c equals to 0. Then if you simplify this one further, square of this will give us 1 over 4. Then minus half multiplied by b will give us minus b over half. So over 2 rather, plus c equals to 0. Then you can multiply through by 4 to clear the denominator. If you multiply this one by 4, we have a. If you multiply this one by 4, we have minus 2b. If you multiply this one by 4, we have plus 4c equals to 0. So you can call this one equation 1. You can call that one equation 1. Also, we are told that this same g of x, which is a squared plus bs plus c, is divided by this, and it gives us remainder of minus 6. So that means if I substitute the value of s to be 1 into this g of s, the remainder should be what? Should be equal to minus 6. So that means if you have also g of 1, which is from this one, so our s will be 1 here. So if I substitute that into g of s, the remainder should be what? Minus 6, as according to what you're having here. So that means if I put g of 1 into this, what do I have? I have a into 1 square plus b into 1 plus c equals to minus 6. So if I simplify that further as well, I have a plus b plus c equals to minus c. You can call that one equation 2. Also, if you follow this one as well, if s minus 2 divide this g of x with the remainder is minus 5. So that means if I substitute the value of s to be equal to 2 into g of s, the remainder should be 5. Sorry, minus 5 rather. So that means you have g of 2 equals to minus 5. So if I put that one into the quadratic polynomial, you have a into 2 squared plus b into 2 plus c equals to minus 5. Simplify that further, we have 4a plus 2b plus c equals to minus 5, equation 3. So we can now substitute this equation 1 into equation 2 and equation 3. So we say from equation 1, we can make a solve by the formula. So that means we'll be having a equals to 2b minus 4c. We can call that one equation 4. So we can now substitute this equation 4 into equation 2 and equation 3. Do you understand that? So that you can be having two variables so that you can solve them simultaneously. So if you make from equation 1, make a solve the formula, you have a is equal to 2b minus 4c call that one equation 4. Then substitute equation 4 into 2 and 3. So put equation 4 into equation 2 first. So equation 2 is a plus b plus c equals to minus 6. So whatever you see a, because from here we said that our a is 2b, our a is equal to 2b minus 4c. So whatever you see a in equation 2, so you put 2b minus 4c. So that means you'll be having whatever this a here, it will be replaced by 2b minus 4c, then plus b plus c equals to minus 6. Collect like times, you have 2b plus b will give us 3b minus 4c plus c will give us minus 3c equals to minus 6. Calculate down equation 5. Also put equation 4 into equation 3. So equation 3 is 4a plus 2b plus c equals to minus 5. From what we got here, this equation 3. Then if you anywhere you see a, so you have to put equation 3 into equation 4. So anywhere you see a, you put 2b minus 4c. So we have 4 into 2b minus 4c plus 2b plus c equals to minus 5. Open the bracket, we have 8b minus 16b, sorry, minus 16c rather, plus 2b plus c equals to minus 5. Collect like times 8b plus 2b will give us 10b, minus 6c, minus 16c plus c will give us minus 15c equals to minus 5. So, sorry, something is common, we can divide through by 5. If I divide through by 5, I have 2b minus 3c equals to minus 1. I can call it down equation 6. So we can now solve equation 5 and 6 simultaneously. We can solve equation 5 and 6 simultaneously now, since that we have two variables left, b and c. So how do we do that? We can see that the coefficient of c here and c here, they are already equal. So that means you can subtract the two equations to get our b. So you said subtract equation 6 from equation 5. So that means equation 5 minus equation 6. So that means you have 3b minus 2b, that will give us b. Then we have minus 3c minus 3c, that should give us 0, equals to minus 6 minus 1. Minus 6 minus 1 should give us minus 6 plus 1, that should give us minus 5. So therefore our b is minus 5. Then put b equals to this into equation 5, this equation 5 here. So that means anywhere you see b, you put minus 5. So that means you have 3 into minus 5 minus 3c equals to minus 6. If you simplify that further, we have minus 15 minus 3c equals to minus 6. Collect like times, you have minus 3c equals to minus 6 plus 15. Then minus 3c equals to 9. Divide both sides by minus 3, c will be equals to minus 3. So we know the value of c, we know the value of b. So we have to find the value of a, so that we can know the quadratic polynomial. So you can put b and c into equation 2. Let's go back. Equation 2 is a plus b plus c equals to minus 6. Since we know the value of our b, we know the value of our c now, we can find the value of our a, so that we can now know this quadratic polynomial. As you have to find g of x, which is the quadratic polynomial. So let's substitute the value of b and c here, so that I can find our a. So from equation 2 says that a plus b plus c equals to minus 6. So our b is minus 5, put that here. Our c is also minus 3. We have this. Simplify it further, we have a minus 5 minus 3 equals to minus 6. Minus 5 minus 3 is minus 8. So a will be minus 6 plus 8, and that should give us 2. So therefore g of s will be equal to 2, which is our a, s squared, minus 5, which is our b, sorry, this is minus 5x, not minus 5b. Pardon me for that, that's an error. This is minus 5x, not minus 5b, because we are dealing with quadratic polynomial. So this is 2s squared minus 5s minus 3. So that's the quadratic polynomial I have to find. Then the second question says that we have to find the zeros of g of x. Zeros of g of x. Now that we know g of x to be 2s squared minus 5x minus 3. So what we need to do is to equate it to 0. So equate it to 0, you have a quadratic equation to deal with, which you can solve using factorization method. And if you use that, you'll be having 2s squared minus 6s plus s minus 3 equals to 0. Forget this one, it should be 5x, not minus 5b. So it should be minus 5x. Now if you do that, you get this by factorization method. 2s is common. Factorize that, you have 2s into s minus 3. Then plus 1 is common between this and this. You have plus 1 into s minus 3 equals 0. Bring this and this together, you have 2s plus 1 into s minus 3 equals 0. Then 2s plus 1 is equal to 0, or and s minus 3 equals to 0 as well. From there, you can find your s to be equal to minus half, or s is equal to 3. So the zeros are minus half and 3. So that's the end of the question number 10a. Very interesting and long. Question number 10b is from binomial expansion. Is from binomial expansion. You have to expand, you have to find the third term when we expand s over 2 minus 1 is to power 8 is expanded in descending power of x. So like I said, this is a binomial expansion. And how do we expand this? We can use a Pascal triangle if you like, but I prefer the binomial way, which is going to be 8 combination 0 into bracket s over 2 raised to power of 8, then minus 1 raised to power of 0, plus 8 combination 1 s over 2, remove 1 from the power, that means you have 7 raised to power 7. Then the power of this one will be increasing by 1, minus 1 raised to power 1, plus 8 combination 2 into s over 2 raised to power 6 into minus 1 raised to power 2. So it continues, but we cannot say we should find the third term, so we don't need to do everything. So this is the first term, the second, and the third term. So you can simplify this further. 8 combination 0 is 1. 8 raised to power 8 is 8. You have 8, s raised to power 8 over 2 raised to power 8 is 256 minus, sorry, multiplied by minus 1 raised to power 0 is 1. So that should give us 8 s raised to power 8 over 256. Then minus 1 raised to power 1 is minus 1. So minus 1 times minus here will give times plus here will give us minus. Then 8 raised to 8 combination 1 is 8. S raised to power 7 is s raised to power 7 over 2 raised to power 7 is 128. Then the next one is minus 1 square is 1 times plus 1 times this plus here plus here. Then 8 combination 2 give us 28. Then s raised to power 6 over 2 raised to power 6 is 64, plus it continues. So the third term, which is this, we are dealing with the third term, that should give us a 28 s raised to power 6 over 64. Something can go, 4 can go here, 4 can go here. That means you have 7 s raised to power 6 over 16. So that means the third term is this 7 s raised to power 6 over 16 for the question number 10b. So we have been solving WAEC 2023 further mathematics theory question. It has been amazing so far. We are in question number, we just concluded question number 10, and we have like 4 or 5 more questions to go in this video. But before we continue, if you are here to subscribe to the channel, please click on the subscribe button on the channel right now. Like this video, comment on it in the comment section. Please, you can share the video. The student that need this resource material, but they don't know where to find it, so share with the student out there so that they will be notified that these resource materials exist. Let's go to question number 11. Question number 11 is from partial fraction. Then we have equation of circle. So question number 11a is from partial fraction. You have to solve this fraction partially. 8s squared plus 8l plus 9 over s minus 1 into 2s plus 3 squared. So which is equivalent, if you want to solve it partially, to a over s minus 1 plus b over 2s plus 3 without the power, plus c over 2s plus 3 raised to power 2. Then from there we can find the LCM of the right hand side, which is this side. The LCM is s minus 1 into 2s plus 3 squared, because we can get this from this. So how do we go about it? Let's go. S minus 1 in this, we are left with 2s plus 3 squared multiplied by 8. That should give us this, plus this in this. That means you will be left with this in this. You will be left with 2s plus 3 multiplied by s minus 1, which is what you're having here. There's an omission here. You'll be having 2s plus 3 multiplied by s minus 1. This one goes in this, so you have one of these multiplied by this. That's what you're having here. So there's an omission here. So also this in this, we have s minus 1 multiplied by c. We have c into s minus 1. So correct that. There's an omission here. You are supposed to be having s minus 1 here. So if that should be the case, this will take care of this, because if you cross multiply, this will multiply this will multiply this, so which can cancel at both sides. So technically the denominators can cancel. So that means you have 8s squared plus 8s plus 9 equivalent to a into this plus b into s minus 1 into 2s plus 3 plus c into s minus 1. Then from there, what can we do? We need to start finding the value of our a, b, and c. And how do we do that? It's quite simple. We can find the value of our c, this c here, because if you can eliminate this, make this x here 0. Or sorry, if you make everything inside the bracket 0. So how do we do that? You can see that 2s plus 3 is common to this, and this one is common to b, is common to a. So that means, how can we make this one 0? Everything inside the bracket is 0. So that would mean if you make our x to be equal to minus 3 over 2, if our s is minus 3 over 2, then this one becomes 0, this one becomes 0 as well. Because here you'll be having minus 2 into bracket minus 3 over 2. 2 can cancel 2. So you're having minus 3 minus 3. That minus 3 plus 3, that gives us a 0. So that means if our s is equal to minus 3 over 2, then this one becomes 0, this one becomes 0. So let's do that. So we put that here. We have 8 into minus 3 over 2 squared plus 8 into minus 3 over 2 plus 9 equivalent to, this one becomes 0, this one becomes 0. So I mean you are left with c into minus 3 over 2, which is for x here, minus 1. Then what can we do? We have minus 3 over 2 squared. That gives us a 9 over 2, 9 over 4 rather. 9 over 4. Then 4 can go in 8. That will give us 2. 2 times 9 give us 18. Then also 2 can go in 8 here. That should give us a 4. 4 times minus 3 give us minus 12 plus 9. If you find the LCM here, that means you have a minus 5 over 2 multiplied by c, give us minus 5 over 2c. 18 minus 12 is 6 plus 9, that gives us 15, equivalent to minus 5 over 2c. Cross multiply, we have 2 times 15, that should give us a minus 30. 30 equals to minus 5 over c, minus 5c rather. We can divide both sides by minus 5, that should give us c to be minus 6. So we know the value of our c right now. So how do we, next we can find the value of our a, because this b and c also have something in common, which is s minus 1, s minus 1. So if you can make this one 0, that means this one becomes 0, it also becomes 0, so you can find a. Then what will be the value of s to make this one 0? That should be 1. So if s is 1 here, that we have 1 minus 1, that gives us 0. 1 minus 1 also gives us 0 here. So when s is 1, so put that here into this, you'll be having 8 into 1 square plus 8 into 1 plus 9 equals to, everything here becomes 0. Then here you'll be having a into 3 times 2 times 1 plus 3 squared. So 1 square is 1 times 8, that we have 8. 8 times 1 is 8. 8 plus 8 give us 16 plus 9, that should give us 25. Then you have 2 times 1 is 2 plus 3, that gives us 5 squared, it gives us 25a. Divide both sides by 25, that gives us a to be 1. So we know the value of our a now. Then we need to find the value of our b. But there's no way we can eliminate this one and this one to get our b directly, because this one and this one does not have anything in common to eliminate. So how do we go about it? We need to expand the brackets. we need to expand the bracket. We can expand this. So what do? Expand 2x plus 3 in squared. That means you have it 4x squared plus 12x plus 9. Open this bracket as well. And that means you have a 2x squared plus 3x minus 2x plus 3 minus 3. Then open this bracket, you have a cx minus c. Also use a to open the bracket. You have a 4ax squared plus 12ax plus 9a. Or use b to multiply the bracket as well. You have 2bx squared plus uh pardon me for that, 3x minus 2x will give us a hex multiplied by b, that will give us bx. Also we have b times minus 3 give us minus 3b, cs minus c. Then from there we can collect like times, bring those ones that have a power of s squared together. So that means you have a 4a then plus 2b, then factorize s squared out. So you have a 4a plus 2b, then s squared outside. That means you have factorized s squared. Then bring those ones that have coefficient of x together. So that means you'll be having 12a plus b plus c into bracket x. So you have also factorized x out here as well. Then bring the constant together. The constant are 9a plus 9a minus 3b minus c. So so technically everything you're having here look like the left hand side because it's a quadratic expression. So everything here also look like quadratic expression where your 8 is equal to the everything inside the bracket. 8 is also equal to everything inside the bracket here. 9 is equal to the constant here. So don't forget our aim is to find the value of b. We know the value of our a, we know the value of our c, so we can find the value of our b here. So that means you can compare both sides. You can compare the square, you can compare the equation of x, or you can compare the constant. So how do we do that? You can compare the constant. So that means you have 9 at the left hand side equals to 9a minus 3b minus c. Our a is 1 and our c is minus 6. Put that here, you have a 9 to 9 is equal to 9 minus 1. 9 is equal to 9 into 1 minus 3b minus open bracket minus 6. Then this will give us 9 minus 3b plus 6. Then 9 plus 6 is 15. 9 is equal to 15 minus 3b, collect like times, minus 3b equals to 9 minus 15, minus 3b equals to minus 6, b will be equal to 2. So therefore, when you solve this fraction partially, you have 1 over s minus 1 plus 2 over 2s plus 3 minus 6 over 2s plus 3 all squared. So that's the solution for question number 11 A. Question number 11b said that, let's go back. The coordinate of the center and the circumference of a circle are minus 2,5 and 6 pi units respectively. Find the equation of the circle. Like I said, this is a equation of a circle. We are given the center of the circle as the coordinate of the center of the circle to be minus 2,5, and then we are given the circumference of the circle to be 2 pi r. Sorry, circumference of the circle to be 6 pi rather. So, and we know that circumference of a circle is 2 pi r. That's the formula for circumference of a circle. So that means if you equate this to the value of the circumference of the circle given to us, we have 6 pi equals to 2 pi r. From there, we can get the radius of the circle because 2 can go in 6. Pi can cancel pi, so radius will be equal to 3 units. Now that we know the center of the circle, we know the radius of the circle, then we can find the equation of the circle. So the equation of the circle with center a comma b, radius r is s minus a square plus y minus b square equals to r square. Now if this is our center and this is our radius, so the same thing, that means our a will be minus 2, our b is 5. So that means you have s into minus 2 all squared plus y minus 5 all squared equals to 3 squared. Simplify that further. Minus minus give us plus. Then 9, you have a 9 here. If you expand this bracket, we have a s squared minus 4s plus 4. Expand this bracket, we have y squared minus 10y plus 25 equals to 9. Then take like times, you have x squared y squared plus 4x minus 10y. Then 9 comes here, you have 20. Oh, sorry for this. Okay, so we have 4 plus 25 give us 29. Sorry for that. 4 plus 25 give us 29. This one comes here, so we have 29 minus 9, that gives us 0. So therefore, if you simplify further, we have x squared plus y squared plus 4x minus 10y. 29 minus 9 gives us 20 equals to 0. So this is the equation of the circle we have to get from the question number 11b. Question number 12 is from cumulative frequency curve. OGIV is from cumulative frequency curve. We are given this table that shows the distribution of marks scored by some candidate in an examination, and the mark is given as a class interval from 11 to 100, and their frequency are also given. We have to construct a frequency table for this distribution, draw a cumulative frequency curve, which is OGIV. Then from the graph, we have to do find this. So given the frequency table already, to draw a cumulative frequency table, so we need to add some things to the frequency table to get cumulative frequency table. So we can rewrite this frequency table like this. This is the class interval, which is represented by marks. Then this is the frequency. Then to get the cumulative frequency table, we need to add cumulative frequency to the table and also upper class boundary. But from from class boundary, we can get upper class boundary. So we can put class boundary here as well. And under the histogram we solve, I told you how we got class boundaries. Remove 0.5 from here, you get this. Add 0.5 to this, you get this. Do that for everything, you get these class boundaries. Then from the frequency, you get cumulative frequency by cumulating your frequency. So you have 5 here. Then 39 plus 5 will give us 44. 44 plus 14 will give us 58. 58 plus 40 will give us 98. 98 plus 57 will give us 155. 155 plus 25 give us 180. 180 plus 11 give us 199, 191. 191 plus 8 give us 199. 199 plus 1 give us 200. So that is the cumulative frequency, and the last value here should be equal to the total frequency here if you want to do that. So we have been able to construct the cumulative frequency table. Now we can draw the OGIV now, and the OGIV is to be drawn using the cumulative frequency on the vertical axis, which is the y-axis, then the upper class boundary on the x-axis. From we use 20.5, 30.5, 40.5, and so on to 100.5 on your x-axis. So if you draw that correctly, you will be having something like this on the screen right now, with our cumulative frequency on the y-axis and our upper class boundaries on the x-axis here, and the graph properly scaled. We can see that we are having 20 units for 20 units for 2 centimeters on the y-axis, and 10 centimeters to represent 2 units on the x-axis as well. Then from there, because the graph is not starting from the origin, so you can put a jagged line here, so that will show that you are not starting from 0. Then from the first one, if you go back, when our class boundary is 20 points, upper class boundary is 20.0, cumulative frequency is 5. So if you plot that, we have that here. The first aesthetic is here. Then the next one, if you go back, when it is 44, the upper class is 30. If you go back here, so 44 is right here. Then this is upper class boundary 30.5. Then let's go back again. When it is 14, sorry, when it is cumulative frequency is 58, then the upper class boundary is 40.5. If you plot that against that, you have the aesthetic here, and if you plot the remaining one, you have this kind of plotting which you can join together from here to this one to give us the cumulative frequency curve, which is the whole give you have to draw. So if you draw your own perfectly well based on the table we have here, then you should have this kind of curve as the whole give. Then let's go back. The question says you should use the curve to estimate the number of candidates who score mark between 240 and 58. Sorry, number of candidates who score marks between 24 and 58. Pardon me for that. Now it's quite simple as well. You can get down from your graph as you have been instructed on. So go to your cumulative frequency. Sorry, your don't forget that this number here is representing the marks. This class interval that we got, this class interval we got the class boundary from it, and it's representing marks. So go to or it's representing marks. Go to the SRZ where that's where your mark is. Then locate 24. Then trace it to the graph. It will go to the y-axis. Then you know the value of 24. Then go to 58 as well on the SRZ. Trace it to the curve. Click to the y-axis. You know the value of 58 as well. If you do that, let's go back again. For 24, 24 is right here. Then if you trace it to the top, you get 20. Then for the next one is 58. 58 is right here. Sorry, 58 is right here. Trace it up as well. You get a 140. 140. So, pardon me, let's go back. Then that means you'll be having 143 minus 20 that you got on the graph. And that should give 123 candidates. Then also you have to get the lowest mark for distinction if 12% of the candidate pass with distinction. So if 12% pass with distinction, how many students fail to get distinction? That means 88 percentile will fail, because if 12% pass, so 12 minus 100 will give us 88. So that means 88% failed, and that should give us 88 percentile. That will be 88 over 100 times the total frequency is 200, and that should give us 176 mark, and that's the position of it. So go to your graph, go and locate 176. So 176 is right here. 176 is right here. Trace it to the graph and trace it down, and whatsoever you read there, that should give us the value of the value of 68.5 mark as the value of the mark for distinction. So sorry, the lowest mark for distinction rather to be 68.5 marks. So that's question number 12 and give as you have been able to solve step by step. So you may need to draw your own graph properly to be able to see what you have drawn here, and if you do it, you can compare it to what you have here on the screen right now. Question number 13 is from binomial distribution. It's from binomial distribution, and we are told that a bag contains 16 identical balls, of which 4 are greens. A boy picks a ball at random from the bag and replaces it. If this is repeated 5 times, what's the probability that he did not pick a green ball and pick a green ball at least 3 times? So like I said, the question is from the binomial distribution probability. Now from that, we know that in binomial distribution we need to get the probability of success and probability of failure. We are told that there are four green balls there. If you now pick one of the ball, that means you have a probability to be 1/4. Then to get probability of failure, that will be Q, and then that will be 1 minus probability of success. That will give us 3/4. Then using the formula for binomial distribution, we have a probability of the event to be equal to NO combination R into probability of success of the N multiplied by Q raised to power N minus R. So for the first question, did not pick a green ball. So that means the value of our number of ball pick is 0. So that means our S will be equal to 0. So P is equal to probability of S equals to 0. That will give us our N. How many balls were how many times did they repeat it? That means you have 5 times combination r, which is our x here, because our x is equal to r at the same time. So x equal to 0, so we have 5 combinations 0 into bracket 1 over 4, which is probability of success raised to power sorry, this is x, not n, raised to power x or r. So that should give us 0. This x here is having here into bracket 3 over 4, then 5 minus r or hex, which is 0. So 5 combinations 0 is 1. 1 over 4 raised to power 0 is also 1 times 3. 5 minus 0 is 5. 3 raised to power 5 is 253 over 4 raised to power 5 is 1000 and 24, and that should give us 243 divided by 1024. So the second one is a probability. What's the probability that he pick a green ball at least 3 times? At least means the minimum is 3 times. So it could be 3, it could be 4, it could be 5. So that we're having that the probability that he pick a green ball at least 3 times is a probability of 3 plus probability of 4, probability of 5, which you can now use this same principle. So that means you'll be having 5 combination 3 into 1 over 4 raised to power 3 into 3 over 4 raised to power 5 minus 3 give us 2, plus the next one 5 combination 4 into 1 over 4 raised to power 4 into 3 over 4, then 5 minus 4 give us 1, plus 5 combination 5 into 1 over 4 raised to power 5 into 3 over 4, then 5 minus 5 give us 0. So if you simplify that further, you'll be having 5 combination 3 is 10, 1 over 4 raised to power 3 give us 1 over 64, then 3 over 4 raised to power 2 give us 9 over 16, plus 5 combination 4 is 5, then times 1 over 4 raised to power 4 is 1 over 256 times 3 over 4 raised to power 1 is 3 over 4, plus 5 combination 5 is 1, multiplied by 1 over 4 raised to power 5 is 1 over 1024. 3 over 4 raised to power 0 is 1. If we simplify that further, we know that the 10 times 9 will give us a 90 over 16 times 64 give us a 1024. Also, plus 5 times 3 will give us 15 over 1024. This time this. Then 1 times 1 times 1 give us plus 1 over 1024. You find the LCM, you'll be having 90 plus 15 plus 1, which is 106 over 1024. If you reduce that, that should give us 53 over 512, or 0.1035 as the value of that. Then the next question, about 13b, is from statistics, and that's from deviation. The deviation from a mean of values from a set of data are minus 2, m minus 1, m squared plus 1, minus 1, 2, 2m minus 1, and then minus 2. We have to find the value of m. So, like I repeated the question here, so the solution is that since we have been told the deviation from the mean as well as this, so you can sum them together to be give us equals to 0, and that should give us minus 2 plus m minus 1 plus m squared plus 1 minus, because plus times minus give us minus here, plus 2 plus 2m minus 1 plus minus again, we have minus equals to 0. So if you collect like terms from there, we have m squared, m plus 2m will give us 3m, minus 2 minus 1 is minus 3 plus 1 minus 2, minus 1 minus 3 plus 2 minus 1, then minus I think I made a mistake there. If you find minus 2 minus 1, that is minus 3. Minus 3 plus 1 will give us minus 2. Then minus 2 minus 1 will give us minus 3. Minus 3 plus 2 will give us minus 1. Minus 1 minus 1 minus 2 will give us a minus 4 equals to 0. So we are having a quadratic equation to deal with, which can be solved using factorization method. And if you understand quadratic equation very well, so you arrive at this. If you solve that, then factorize this, you have m into m plus 4. Minus 1 is common here. Minus 1 into m plus 4 equals 0. So we have m minus 1, m plus 4 equals 0. So technically, m minus 1 equals 0, m plus 4 equals 0. So our m is equals to 1, and our m is equals to minus 4 for question number 13b. I hope you understand what you have done so far. Let's go to the next question. The next question is question number 15. A seesaw. Of course, before we go to question number 15, we were in question number 13 before. And the reason why we don't have question number 14 is that we don't have the question at hand. So it is the one we have at hand. We have access to that what we gave to you. So we don't have question number 14. So the next question we have is question number 15, that say that a seesaw pivoted at the middle is kept in a balance by weight of Richard, which is represented by R, John by J, Philip by P, such that only Richard, whose mass is 60 kilograms, sit on the one side, and if they sit distant 2 meter, 3 meter, and 4 meter respectively from the pivots, and Philip is 15 kilogram, find the mass of John. So the question is from the moment. So now what can we do? What is given to us? We are given 3 people: Richard, John, and Philip. Richard is represented by R, John by J, and Philip by P. You are being told that they all sit down on a seesaw, and it's pivoted as at the middle, and the weight of Richard is sorry, the mass of Richard, rather, not weight, is 60 kilogram, which we can change to weight. So we know that the weight is mass times gravity. So if the mass of the Richard is 60 times gravity, which is 10, then we have 600 Newton to be weight of Richard. And we are told that the Richard is the one at the side. Where is it? Is sit in one side. So Richard is this. Then the remaining 2 people are at the other side. So then John, we are told that John sits. Okay, if they sit distance 2 meter, that means the distance of Richard from the pivot is 2 meter, which is what they are having here. Then this 3 meter belongs to John. So John from the center as well is 3 meter. Then, but we don't know the weight of John. That way we have this to be W, which is representing weight of John. Then the distance of Philip from the center is 4 meter. So that means instead of writing 4 here, we know that from here to here is already 3. That means from here to here will be 1. So we have 1 meter here. So from here to here is already 3. That means from here to here will be 1 meter. So then we know that the weight, the mass of Philip is 15 kilograms, so we can change the weight. So 15 times 10 will give us 150 Newton as well to be. So therefore the moment about the pivot is the clockwise moment should be equal to the clockwise moment as well. So the moment at this side should be 60 Newton, 600 Newton multiplied by the distance, which is 2 meter, equals to the moment at this side should be moment of this plus this. So that means you'll be having the moment from here to here is to be weight multiplied by the distance, which is 3W, plus the moment from here to here, the moment of this from the center as well should be 4 multiplied by the weight, which is 150. So we have W multiplied by 3 for the moment of John. Then for Philip, we have 150 plus times 4. Then we know that the clockwise moment will be equal to the anti-clockwise moment according to the principle of moment. So 600 times 2 give us 120, 1200 equals to W times 3 give us 3W, plus 5150 times 4 give us 600. Then from there you can take light times. You have 3W equals to 120, 1200 minus 600, and that should give us 600. Divide both sides by 3, that means W equals to 200 Newton. So that is, question asks us to find the mass of John, but this one is talking about the weight of John now. Then how do we get the weight of John? I mean, divided by the acceleration due to gravity. So that should give us 20 kilogram as the mass of John. Now, the question number 15b is from the um, force on an inclined plane. Force on an inclined plane. So we are given that a body of mass 12 kilogram rests on a rough plane, inclined at an angle of 30 degrees. So I hope you understand that. Then inclined at an angle of 30 degrees to the horizontal. The coefficient of friction between the bodies and the plane is 2/3. A force of magnitude P Newton acts on the body along the inclined plane. Find the value of P if the body is at the point of moving down the plane and up the plane. Take g to the 10 meter per second squared. So if you draw the diagram for this, you have this inclined plane with the angle of inclination to be 30 degrees, and this is the body, or the body of the body that is trying to slip down and up. Now, of course, now we know that when it comes to the force on an inclined plane, there's the horizontal component of the force and the vertical component of the force as well. The horizontal component is the mg sine theta, which is mg sine the angle, which is 30 degrees. Also, then the force along the vertical component is mg cos 30 degrees, which is talking about, which is the same thing as the reaction of the surface against towards the, what's it called, the mass or the body, the reaction of the surface against with the body. Now your question has also find at the point of moving downward, you have to find the value of P. So now if this mass is moving downward, that means the force, the horizontal force, then plus the force of P should be equal to the reaction of the surface. Should be equal to the reaction of the force surface, which is same as force. Then the force, the, what's it called, the the coefficient of the friction rather. So coefficient of the friction to be equals to the uh sorry, the force, the reaction of this surface should be equal to the horizontal force that is moving this thing back downward plus the force P. And how do we get the reaction against this body? That should be our F equals to uh the omega multiplied by the R. So but our R is going to be mg sine cos theta multiplied by that omega. You have been given the value of the omega is the coefficient of the coefficient of the friction, which is 2/3. So 2/3 times the reaction, which is this downward this, which seems as the equal to the weight of this weight of the body. So the reaction, which is this one going up, is equal to the weight of the body, which is our mg cos 30. So the mass is 12 multiplied by g, which is 120 cos 30. Then that should give us the reaction, the force against this uh the reaction, which is aiming at this force here. Then from there, what do we have? We have the force, horizontal force, plus the P to be mg sine theta, which is our m is 112 times 10, which is 120 sine theta, plus P equals to the force we got here. So we have 120 times half, sine 30 is half, plus P equals to, if you simplify this one, will give us 80 cos theta, so cos 30. So this will give us 60 plus P, If you simplify, this one should give us a 69.82, 69.282. Then if you correct like time, you have a P to be equal to 69.282 minus 60, which should give us a 9.292 Newton as the value of the force P. Then also we have to find the value of the P if the body is up the plane. Then at the point of moving up the plane, that means the force P should be equal to the force, the value of the P should be equal to the force of the what's it called? Should be equal to the force on the horizontal plane plus the friction, the reaction against it, which is our help we got here. The help we got here to be equal to the value of our F we got here, which is 69.282. That is the reaction of the body against the reaction of the plane against the body. So if you these things you got to move up, that will be the force on the horizontal plane plus the reaction of the body. So that should give us the force on the force on the horizontal plane is 120 sine 30 plus the reaction of the body, that should be 69.2882 that we got from here. So that should be 60 plus 69.282, and that should give us 128.282 Newton as the force, as the value of P for that question number 15B Roman figure 2. So we have been able to solve all the theory question except question number 14 that we don't have access to the question. Now I believe you have been able to learn one or two things from this video, and we have enlightened you one way or the other. And please don't go without sharing this video. If you are yet to subscribe, please click subscribe button so that you will be notified whenever we post information on this platform. Thank you, and God bless you. We'll see you in the next video. Bye.